Welcome back. In this video, we are going to look at what are static versus dynamic expressions and why DAX becomes highly important when we have to implement dynamic aggregations in Power BI. So let's get started. Let's look at this example. We have again our employee records, right? And what we need to find out is that what is the average salary of male versus female, right? So what is that we are going to do? In Excel, we are going to just sort it and we are going to take up the total salary, which is 2,55,000 for females, and there are 3 females, so the average will be 85,000. Right, which is this plus this divided by 3. Similarly, for the male employees, it is going to be the sum of all the salaries divided by the number of employees, and that is coming out as 5,25,000 divided by 5, which is 1,05,000. What do we see here? One difference from what we were doing before is that I am now not dependent upon row by row calculation. The calculation here is depending upon a context. The context here is gender. So if I'm using the context as gender, or in other words, I'm grouping by gender, so the salary looks like this one, and then there is another group which looks like this one, and we can have the average salaries for female as 85,000 or for male is 1,05,000, and we conclude that okay, male employees on an average are earning more than female employees. Suppose at the same time you need to change the context, and now you want to get the average salary by employee type. So then I'll have to get the average salary of all the contractual employees, which comes out to be 82,000, and the salary of the permanent employees, it comes out to us like 1,23,000. So what we are seeing is the context gets changed, and based on the context, the calculation is getting changing. It can also happen that we want to get the average salary by employee state, and then it's going to go like this. For California, it's coming out like this. For Massachusetts, it's coming out like this. For New York, it is this, and for Texas, it's coming out like this. So in the end, if you see, it looks like how we used to do calculate the pivot tables, right? So let me create a pivot table. And implement the same thing. So we want by gender, I want the average salary. I'll change the aggregation here and say salary. It comes like this. Instead of gender, you remove gender, you bring in employee type. It changes, right? If I remove this, I bring in employee state, it again changes. So what is happening? My calculation remains the same, which is average salary. But the context in which, or the slicer which we are using to do the calculation, that changes dynamically. In such situation, I cannot rely on a row by row calculation to get this thing done. For example, what will be the row by row calculation in terms of average? What do you mean by average salary of a single employee? It does not mean anything. Average salary of a single employee is the salary itself. So that does not make sense, right? So it's important to understand that in these kind of calculations, I need to have a core calculation which is waiting for the context to be supplied in order to do the calculation. Let's take another example. Just like average salary, let's think about the company situation where company is hiring employees, and some of the employees are getting high salaries. For example, if I sort this in the descending order, some of these employees are getting really high salaries, and some of the employees are getting low salaries. And these employees are undergoing these employees are doing projects, and they are spending hours in that. So for the company, there needs to be acceptable billing rate. So a highly paid employee, if that employee is not working as much, the productivity of that employee is going down, and that's basically a lost deal for the company where the company is paying but not able to convert those to billing hours, compared to employees which are paying low but they are really being overworked, and hence that's again a not good situation where the employee may feel dissatisfied and ultimately leave the company. So in the same situation, if I have to calculate, say, employee wise say productivity. So for calculating the employee wise productivity, it will be simply the salary divided by the total hours worked. So if I do that, what we see is that there are some employees for which the per hour cost comes out to be really high. For example, in this one, this person is getting 1,50,000 as the salary. So per hour, but worked for 100 hours, the per hour is coming as 1,500, which is pretty high. But look at this employee, which is getting just 50,000, which is like 1/3, but it is working more than the allotted hour, more than the hours of this employee, and hence this comes out to be pretty low. So how do you strike a balance here? So in this case, what we see is that we actually did a row by row calculation, which is fine. But think about this. If I have to do the same thing by gender, I want to calculate the productivity of male versus female. I want to calculate productivity of permanent versus contractual employees. I want to calculate productivity by state. How do we do that? Say, if I say sort it by employee type, so should I say that my productivity for contractual is going to be the sum of this? Does not make sense. Should it be average of this? We can think of. But what do we see here is that we have already taken the ratio, and once I have done the ratio and then I'm doing an aggregation, that's not the sensible way to do it. The sensible way is that for contractual employees, how much is the total amount you are spending in salary and how much is the total work these employees are doing. So this total divided by this total is actually the right productivity value for the employees. So for example, for contractual, the total salaries dispersed is 4,10,000. So let me actually do that. Sum of this total, all the contractual employees, and what is the total hours? That will be all these values. So what is the productivity for contractual employees? It will be this. That's the right answer, rather than if I do an average across, which is coming as 633. The correct answer is 554.05. And similarly, if you want to do it for permanent employees, you're going to take the sum of these salaries which is disbursed divided by sum of the hours which is done. So what's the formula coming up? The formula coming up as like this: sum of salaries divided by sum of hours worked. And this formula is the core formula, and the context in which this formula needs to be calculated is decided by what is the slicer I'm choosing. If I'm choosing gender, then I will sort it by gender, and the calculation will be sum of salary of females divided by sum of hours worked. For male will be sum of salaries of male divided by sum of hours worked, and hence the calculation is happening dynamically depending upon what is the context applied, and hence this kind of calculation or aggregation is called as the dynamic aggregation, against the static calculation where the calculation is already done and it is already created as a new column. So when we used new column in DAX, we created static calculations. When we used a formula here and I am waiting for the context applied, basically I am doing is a dynamic aggregation. And this dynamic aggregation is something you don't know. You don't know from before that whether in my chart I am going to show by, say, contractual by permanent, or in the chart I want to show by gender, or in the chart I want to do by show by state. This is going to be known at the time of creating the chart only. So this formula is waiting for the context till the point that is supplied in the chart, and hence it is called as a dynamic aggregation. And this is where DAX has one of its biggest advantage, where you can create dynamic aggregations in Power BI. Let's see how. Alright, let's do the same two calculations what we did in Excel now in Power BI. The first would be the average calculation. So what we need to do is I want to get the average salary calculated by employee type, or I want to do the average calculation by gender or by state. So how do we do that? If I go ahead and say, okay, let me go ahead and create a new column. But remember, when you say you're creating a new column, you're creating a static calculation, which is going to be doing the calculation row by row, which is equivalent to in Excel, you're clicking on a cell corner and dragging it down. So if I try to do that, let me create this new column and you say average salary. And for calculating the average salary, I'm going to say average, and let me refer this salary column, and I say okay. What happens? Since the calculation is going to be happening at row by row, but the calculation which I have provided is average, it is simply doing an average of the salary column, and it is printing out the overall average in each row, which if I go to the data and validate that, we have the salary. If I just click on it, it is showing as if I click on it, it is showing as 97,500. That's what it is producing. So it is doing the right job of creating a new column, and it is doing the calculation row by row, but it is not what we are looking for. This doesn't help out in anything. Now if I do an average salary by employee by male or average salary by female, is going to return the same thing, which means that let me just go to the report section and let me create a simple column chart. And what we see is that we have this average salary. Let's put that in y-axis, and let's put the employee type in the x-axis, and then the average salary, we basically go ahead and put it like this. And what we see is both of them are going to be showing the same, but we know that that's not the right thing to do. And now if I change from say employee type to gender, it's really not helping because it's going to be the same, and this is clearly wrong. So we should not use new column, which is static calculation, where you are dependent upon a context or the slicer to get the calculation done. So let's revert back and delete this calculation, and let me create a new measure. And this is what we use for dynamic calculations or aggregations in Power BI. Let's click on new measure. Let's call this again average salary, and I use average salary, close this and commit this. There are a few things happening. First of all, when I created this average salary as a measure, I see a measure called avg underscore salary getting created, which has this calculator icon, which looks different from the icon which we created for tax slab. This says that this is a measure and not a new column, and hence this is something which will be used for dynamic calculation. And second thing to note is that there is no new calculation done, because the calculation is not static. It's just like function in Python, where the function template is there, but it is not yet executed. It will be executed, say, from the main program. So it is not yet executed. So how do we say that it is dynamic? Where is the dynamic nature? I've got this done, but how do I use it? That's where we go back to our visual, and now instead of that the old one which we had already deleted, let's bring in the new one and put it in the y-axis. And what do we see? My average salary is suddenly looking different, and for male it is coming as 1,05,000, and for female it is coming as 85,000, which we have already seen before when we created the pivot table. So instead of employee state, let me bring in employee type, and not employee type. Let me bring in the gender, and this is what we're getting. Similarly, remove gender and bring in employee type. This is what is the context which I'm setting up dynamically here. And see the calculation, it is happening also dynamically. So we go here, remove the gender, bring in the employee type, and we see the exact same value as we saw in Excel. What is that we are doing? The calculation remains the same, the context changes. The context can change. Instead of employee type, now I can bring in employee state also. And similarly, what we see is in California, the average salary is pretty high compared to Texas, and then New York, and then Massachusetts. So same calculation, changing context. That calculation happens on the fly. So basically, if I have to showcase how this is working in Excel, it's exactly like, okay, first the context is California. So basically, you go to your data and then you filter this by California. Filter this by California. So I select for California. For California, my average is coming out as 1,25,000. Is that so? Yes. Then what is the next one? Next one is Texas. Okay, so we will go ahead and select Texas, and go ahead and select Texas. Now, what is the average salary? Average salary is 95,000. Let's go and check for Texas, coming as 95,000. So so if you see in the back end, it's working for each of the value again and again. So for California, the calculation is happening, then again for Texas, again for New York, and again for Massachusetts. That's why the calculation is only possible on the fly at the time when we supply the context, and hence it is dynamic aggregation, and hence new measure is what is to be used for this kind of situation. And now we see that we just could not do this in Power Query. How many tables would have created? One we would have done group by state, one we would have said group by employee type, one we would have said group by employee gender, right? So we could not do in Power Query. So this really sets up the need that, hey, DAX expression is something useful, and creating dynamic aggregations, you need that. So similarly, let's go back and do the other calculation about the productivity. So we know that again for the productivity, what will be our rule? Say our rule or our logic, our function, that will be your sum of total salaries dispersed divided by sum of total hours worked. So again, we go to home, and again think about it whether you should be creating a new column or a new measure. If you do not need to do a row by row calculation, do not go for new column, right? Here it is again based on the context. So let's click on the new measure and set the formula. The formula will be productivity, or then we bring in the sum of salaries divided by sum of hours worked, and this is my formula. If I say OK, again you can see that the productivity gets created. One important thing to note here is that when you create any measure, that measure you can define a home table. So you want to keep that measure in this table or some other table, because that measure does not have a table dependency, right? You can have in a measure, the formula can have one column from one table, another column from another table. So there's really no concept of say which table it should be created by default. It can be any table, but depending upon situation, for example in this one, it really makes sense that the measure is created under this table. But if you want to change that, you can come here and you can change the home table of that given measure, right? So our measure is created. We see that there is no new column created, and that's what happens. Any dynamic measure which is created does not take physical space, but it takes time or compute during the runtime rendering. So with that, if I come here and remove average salary and bring in productivity, we get into an error, and it says that the function sum cannot work with value of type string, and that is happening simply because the data which we have, I think, is not of the right data type. So we quickly go to Power Query, and we see that salary is okay. How about number of hours worked? Let's check that where it is. Hours worked. See, it is showing as any. This needs to be changed to whole number. Now both are numbers and that should work. So let's go to close and apply. It's going to apply the change and that should fix it, right? And what we see is again California, basically the per hour billing what's happening is pretty high, right? So for the hours invested, the compensation paid per hour is really high in California compared to Texas, Massachusetts, or New York. And again, the good thing is that you can change the context on the fly. Now I can say do it by employee type instead of state. Perfectly doable. Instead of employee type, I want to bring in gender. Again, the calculations change on the fly, right? That's the utility of tax expressions in a dynamic way, and that's where you get to use the new measure.